In this clip we're going to explore how we use powers or indices. Let me give you an example. So if I said I've got 2 squared times by 2 squared, what's the answer? Well, first of all, let's think how else we could write this. We could write it as 2 times 2 times 2 times 2. And we know that we can simplify that because it's a number that's multiplied by itself and 4 times, and we've got 2 to the power of 4. Now that's interesting because actually all we've done effectively, it looks as though we've multiplied our powers, but actually we've added them. Let's prove that by doing another example. Let's make it a bit tricky this time. Let's say we've got 3 to the power 3 multiplied by 3 to the power of 4. Let's write it out in the same way. So 3 times 3 times 3 times by 3 times 3 times 3 times 3. Okay, so we've got 3 to the power 3 and 3 to the power 4. Multiply it out. 1, 2, 3, 4, 5, 6, 7. See, we've got 3 to the power 7, which proves to us that we add those together. If we add the powers, we get to 3 to the power 7. Be very careful, because one of the common mistakes students do is to say it's multiplication, so that must be 3 to the power 12. And you can see that that cannot be the case. Okay, so the thing that we've learned when we're dealing with multiplication of powers, and it doesn't matter what it is, so if I said what's a to the power 7 multiplied by a to the power 6, you would now tell me that the answer is not a to the power of 42, it's a to the power of 13. And you'd be absolutely right. Now, let's look what happens when we are dividing using powers, okay? So let's think of another example. Let's do something like this. Let's do what is 2 to the power of 4 divided by 2 squared. All right, so let's work this one out. So we've got 2 times 2 times 2 times 2. This time we're dividing by 2 times 2. So there's 2 to the power 4 and there's 2 squared. So 2 2s are 4, 2 4s are 8, it gives us 16 divided by 4, and our answer is 4. Now we know that 4 can be written as 2 squared. Now let's use what we've just learned and go back up here to prove to us that 2 to the power of 4 divided by 2 to the power of 2 actually gives us 2 squared. There it is. And this time, actually what we've done is subtract our indices. Now you could say, oh, it looks as though we've divided them. So let's have a look at another example to see, to prove the point that we've just been making. Let's do something this time. Let's do 2 to the power of 5 divided by 2 squared. Okay, let's see what happens now. So we've got 2 times 2 times 2 times 2 times 2. That's our 2 to the power of 5, and we're dividing by 2 times 2. So 2 2s are 4, 2 4s are 8, 2 8 16, 2 16s are 32. So that's 32 divided by 4. The answer is 8, and we know that 8 is the same as 2 to the power of 3. Now that proves the point that actually when we are when we are dividing powers, we simply subtract them. Now there's one final point that I want to look at, which is, I think it's quite challenging, but it's quite interesting. So let's say this time I've got 4 squared divided by 4 squared. Now you're going to say to me, well, we know what we're doing. We subtract the indices quite correctly to give us 4, but we'd now say 4 to the power 0, wouldn't we? Because 2 take away 2 is 0. Now let's have a look in practice at what we've got. We've got 4 squared, which is 16, divided by 16, and what's the answer? What's 16 divided by 16? and the answer is 1. Now that's really interesting because what we've just learnt is 4 to the power 0 is actually 1. And that's a really, really important thing for us to learn when we're dealing with powers. And what we've actually learnt is any number to the power 0, it doesn't matter what it is. So if I said to you, what is 12 to the power 0? 12 to the power 0 is 1. What's 87 to the power 0? The answer is 1. And that'll do us for now.